All right, so tonight I was planning on diving into a little bit of like BSP related things and taking a look around at some of the other BSP servers that are like a little bit less common. I feel like in Scala we always talk about Bloop and recently SBT more, but for like quite a while ago, Mill actually has an implementation of the build server protocol as well. And Bazel also has one, and we don't technically support either of those in Metals. And it's been a while since we actually since I tried out the Mill one, and I've never tried out the Bazel one. So I'm tempted tonight to actually spend a little time and I don't know, just go through the various BSP implementations. Try them out with Metals, see where what the status of the Mill one is, and then even try out the Bazel one. We don't support Bazel technically in Metals, but I'm really curious to see if you did have a Bazel workspace and you produced the BSP directory with, I'm assuming, a Bazel.bsp file, if it would work well. So yeah, we can try it out tonight. But actually, hold on one second, because I feel like I'm hearing myself. All right, fixed. All right, so let's take some notes. Streams. What's the plan for the day? Like I said, look through the various BSP implementations for Scala. And yeah, so Bloop, which everybody probably knows, SBT, which is the new kid on the block, Mill, which is there, but I don't think fully completed. At least the last time it wasn't, I looked. And then also Bazel, take a look at that. So, and I'll also maybe show some demos of how Metals uses different BSP servers, or how you can choose to use one over the other one, or how you can create a configuration for it if you don't know how it all works. So let's jump into just a workspace. I think I actually have a BSP test. Yeah, so this is a good one to try out. I think I'm actually using a snapshot of Metals, so let's actually grab the latest version of Metals. Let's do this. Yeah, so I think the easiest way to show this is just with an SBT workspace, and then also just a normal SBT workspace, because I can show both build servers with this one. But let's go to the latest actually. Let's say 150. Open this back up. Oops. Close install. Installed. Restart the server. All right, so if you're in a fresh workspace, and you like just open it up for the first time, you get the prompt, it will prompt you to like import the build. You're using Bloop, right? And you can confirm that if you go into the doctor, and you see your build definition is coming from SBT, but then your build server currently being used is Bloop. And again, that's the default. We can go into like why that is, but probably even a better way to tell, or like a better like explanation of that is if you actually go to the Metals website, we have a blog post, called SBT BSP support, and we go into like a little bit of the details of the differences between SBT build as a build server and Bloop as a build server, and then also how to jump back and forth and stuff. So if you're curious about like how to actually use this, this is a good place to look for that information. But yeah, so like the build server you're currently using right now is Bloop, which is the default. Then if you actually look at your directory here, you'll see, like you won't see it right now, there's no .sbt directory. So let's try to switch. So the way that you would switch is, there's a couple different ways to go about it. You could either start from like running SBT from the command line, like you could say sbtn and start a server, and then you could actually attach to it from Metals. And what happens when you do this is it automatically will create a .bsp sbt.json file, and that has all the information that you need to connect to it. And if you're like unfamiliar with BSP, you'll notice that like in the whole editor ecosystem, we have like so many protocols, right? Like we have LSP, which is language server protocol. So think of that being communication between your editor and a language server for like intelligence about your code. So everything that you would expect about like go to definitions or hovers or those types of things are all covered there. Then between your build, between your like language server, which in this case is Metals, and your build server, there's another like line of communication where like Metals isn't doing the compilation itself. It's actually like handing it off to something that speaks BSP, which knows how to build your code, test your code, give you some more information about your code, about like where certain jars are located, or kind of all sorts of stuff about your not necessarily about your build definition, but about the code that you are trying to build. So yeah, if you view it that way, you have like an arrow between your editor and Metals, and then you have another arrow that you can kind of see here, which would actually be between Metals and your build. So actually, like this is interesting because like this diagram here is I mean it's accurate, but there's also like different ways that this could be. It doesn't necessarily need to be build tool editor. There's also like a language server in between here sometimes, because it's not really that VS Code is talking directly to via BSP to SBT, for example. Like that actually wouldn't happen. So but yeah, the site is really good. It's inspired by LSP. It has tons of information. There's a really nice specification for it. Yeah, and we'll maybe go into this a little bit as we dive into stuff. But one of the ways, so like we cover that you can just do like SBT. It would create the .sbt file or .bsp sbt.json file, and it would also like start a server in the background. But if you wanted to like fully do it within Metals, you could as well. There's a Metals generate a BSP config command. And what this does is it looks at the current build tool that you're using. So in this case, it recognizes that you're using SBT. It sees if it is a BSP enabled, I think build tool is how we like the terminology we use in Metals. And if it can serve as a server as well, then it knows how to create a BSP directory, right? So if we go back here and look, there's no BSP directory right now. And if I do this, it's running sbt BSP config. And what that does is it will create that BSP directory. So if we like let this finish for a little bit, you'll see that it creates it, maybe. Takes a bit. Come on. There we go. All right, so now you see on the right-hand side, we have a .bsp directory. If we go into this .bsp directory, you will see a sbt.json file, right? So let's actually try to go into that as well. I'll show you what's in there. BSP. It's not a ton of stuff, but yeah, it just has like the name of the server, the version of the server, what BSP version it is speaking, the languages that it knows about. So in this case, it knows how to handle Scala, and the args, which is actually how to start it. So if you look at this, like this is my JDK that I'm using Growl, so that's why you see the crazy version. And you'll see some args that we do, and a class path that we pass in, and then SPT launch jar. And then, yeah, you see the whole thing. So that's how Metals knows actually how to start SPT as a server. It's not actually that like Metals knows a whole bunch of information about SPT and it knows how to like start a server. It's simply just following the BSP protocol, where according to the protocol, it should have everything that's needed inside of this file to connect to the server. And that's what you're seeing here. So what happens after this was created was that it's created it. After it created it, it then connects to it. So now if we go back to Doctor, we'll see that not only is our build definition coming from SPT, but our build server that is currently being used is also from SPT. So everything should work the same way that you would expect for it to work if you were using Bloop. There should literally almost be no difference. And like some of the differences that existed when SPT first came out with as a build server have been fixed. Like for example, one big one was that you were unable to run your code. So like, yeah, you just saw a little bit ago, right? Like I'm using SPT as a build server, and it used to be that you couldn't run your code. So like this used to not work. Now you see that this works. So like you can via BSP, so like there's another protocol, right? Like you have LSP between editor and language server, BSP between language server and build server, and now you also have this other protocol, DAP, which is the debug adapter protocol, which is between your debuggee and your debugger. So in this case, it's SPT, and the debuggee in my case, I believe, is NeoVim DAP. So yeah, there's like 3-4 different arrows of protocols that are all communicating here, making this stuff work. So yeah, this was recently added with SPT. I don't know. I think it's in the most recent version of Metals. But yeah, so this works now too, and this was like a huge thing that wasn't working. So it's pretty rad. But one thing I haven't tried in a while was, you notice that this workspace doesn't just have a build.spt, right? So let me go back here. So we have a build.spt, but we also have a build.sc. And let's try to align these, because like I said, I haven't looked at this in a while. So let's make sure that these are the same, right? So we have same Scala version, set these to 13. They're both using mdoc. Yeah, so pretty much the same thing. We'll just assume they're the same. So one thing that's pretty cool, I think, is like if I go back to Metals Doctor, I'm using SPT as my build definition, and I'm using SPT also as my build server, okay? So let's change that back. So at least in NeoVim Metals, the way you change that is Metals BSP switch. And this will show you like you're currently using SPT as your build server. You want to switch, what other options are there? So if you're in a workspace that has a build tool that Metals knows about, Bloop will always be an option, like no matter what. It just default will be there. And then it will also tell you what you're currently using. So in this case, there's only two options, Bloop and SPT, right? So if I say I want to use Bloop, I just say, oh, wow, I want to go back to Bloop, and then that's pretty much it. Like the SPT server gets shut down. It's actually something to keep in mind too, right? Like if you're using SPT as a build server and you start it with Metals, then like split and go into SPT shell, and you're like doing stuff in SPT shell or whatever, and then in Metals you actually switch back to Bloop, it'll shut down the server and it will like kill your session that you have open in the shell, which is a little bit annoying, but something to keep in mind. And that's why, like, if you are going to use SPT as a BSP server, I'd probably like recommend to just start up the server first, have it running, and then have Metals attached to it and connect to it, and then it's the same process basically. And then if you do switch back to Bloop, you don't actually kill your open shell that you have as well. So it's like one little difference. But yeah, so like we have, so now if we look back at Doctor again, we have our build definition coming from SBT, and now we've switched back to Bloop, right? So what if I want to actually switch build definitions? Like I want to use, for example, Mill as my build definition. You can do that. So you can do Metals, instead of BSP switch to switch build server, you can do reset choice, which is right here. If you're a VS Code user, you can actually do this a little bit different, and you can open Doctor, and Doctor will have like a little reset button right in there, so that you can do it that way. But if not, yeah, you can do it this way too. It's pretty simple. So like, what choice do you want to reset? I want to reset my build tool. You could also reset the build server this way as well. You see it here. So I reset my build tool. It recognizes that there's both a build.sbt in the directory and also build.sc. So it knows, oh, you have an SBT definition, you have a mill definition. Which one do you want to use? Okay, well, I was using SBT. I'm going to switch and say I want to use mill now. And then boom. So it will start using mill now. It'll run the mill bloop install to also get the same bloop definition that it needs from mill instead of SBT. So if I let this finish in a little bit, and then we'll look at Doctor, and you'll see that we're actually using mill now for your build definition. All right, so if we go to Metals Doctor, now we have our build definition coming from mill, and the build server that we're using is Bloop, which is kind of cool. If I do a Metals BSP switch again, you will still see SBT here, right? But if you tried to use SBT, it would not work right. Well, actually, I'm pretty sure what would happen. I don't know. Let's try. I'm trying to actually think if it would just instead pick up the build. If it would, I don't know. I don't know what'll happen. I guess I'm just lying because I really don't know what would happen in this situation. Because it probably is not the most logical thing to work right now. Like, it probably shouldn't work. But I do think it might work. Because if we look at now, Doctor is going to be super confused because we have our build definition coming from mill, but our build server being used is SBT, which it shouldn't work. But I'm pretty sure SBT just loaded up I'm pretty sure SBT just did load up the build definition from SBT, but Metal still thinks we're using the build.sc. So probably if we would edit our build file here, it wouldn't even detect it. Maybe, I don't know. Whoops. Yeah, exactly. So it doesn't even think about watching this right now because it doesn't think you're using it. So it's like not even paying attention to your build.sbt. It's paying attention to your build.sc. So if you did go back to your build.sc then, for example, and change this, then you should get prompted. Oh no, you don't even get prompted here. I don't even know why that is. I think it's just like straight up confused because we're like doing something nonsensical. So let's do a BSP switch back to Bloop, which will make sense. But the whole reason I showed you this was because like you can switch between Bloop and SBT pretty seamlessly. And then also like between mill and SBT for your build definitions in this case. But at the same time, mill also has a BSP server, and I haven't looked at it in quite some time. So let's take a look at it and see if some of the issues that we outlined last time is like still there or not. Actually, it's annoying that I'm seeing out inside of my telescope. So I want to change that real quick. I don't want to see anything inside of out. Okay. So if we jump back to the GitHubs. Actually, no, let's start from the Metals perspective because there's a feature request to support it because right when we added SBT BSP support, like the logical next thing was, well, if you're adding SBT, you might as well add the other ones because there's a lot of like overlap between there. Yeah, as you see, like Bazel is super, it's like one of the highest wanted, desired things. So we'll take a look at Bazel BSP and see, yeah, I've never tried it before. So it's a project by JetBrains. So it's supported well. I'm assuming IntelliJ is using it. Import, compilation, run and test isn't supported. toolchain registration. I also don't know a ton about Bazel, so it will be interesting to see how hard this is to set up, for example. Because my like very limited guess at this point is like, pretty sure they use Coursier. Yeah, so you would use Coursier to use this project, and then point it at your project, call this main method, and then it will create a BSP, like I'm assuming a Bazel.json file inside of your BSP directory. So then when you're in your project, like not this project because it's not a Bazel project, but if actually interesting. So yeah, so normally, right, like when you do the BSP switch, you get two options. You get like Bloop automatically because it's the default, and then also the other one, where in this case it'll be different. It'll actually be if I'm understanding correctly, Metals will just automatically detect that it's in a workspace that it doesn't know how to support the build tool, and therefore it will fall back to the entry that's in the BSP directory, which in this case is Bazel. So it should automatically actually detect that you want to use Bazel as a build server, connect to Bazel, and then maybe work. I don't know. We'll figure that out. But before we look at that, I want to look at the Mill stuff. So let's go back here. Jump to the feature requests. Because yeah, Mill, I have a feature request in here that I was keeping track of various things that were either working or not working with Mill BSP last time I tried it. Mill BSP. Yeah, okay, so last time I looked at this, there was 4, like I would say, like blocking issues that were, in my opinion, like making it pretty unusable for Metals users. So let's take a look at what these were. So one of them is workspace reload. And what this is, yeah, so it's funny because when Metals first started, like everything was super Bloop focused. So some of the names that we actually have for things don't, if you try to map them perfectly to the BSP terms, they don't always make the most sense, but they made sense at the time. And what I mean by that is like, if you change your build definition, it will prompt you to do a build import, right? Because that's what Bloop needs. Like it needs another import of your entire build definition in order to create all the Bloop files that it needs. But in reality, that's like with an assumption that Bloop is, or like whatever build server you're using is writing to disk, right? So like that's one of the big differences between SBT and Bloop, is that Bloop is a build server that's writing your entire, like basically your entire build definition to disk. So then the next time you open up, it's pretty immediate. Like it can just read in the JSON files, slurp it up, and it knows everything it needs to know, and it can just continue. Where if you're using SBT, you'll notice it may take a little longer every time you start up because it's actually reading the entire build definition into memory. And then if you change that, it will execute what's called a workspace reload. So yeah, it just like it's the same thing. Like if you're an SBT user and you change your build.sbt file and you have an SBT shell open, you need to do a reload, right, to like get everything caught up. It's the same thing in BSP land. So the workspace reload is triggered if you're using a build server that supports workspace reload. So in SBT, it's workspace reload. But if you're actually using Bloop and you change it, it's triggering something else. It's actually not triggering a workspace reload. It's triggering a build import. So it's a little bit different. Like it's probably a small distinction that's probably not super important to know really. But the reason I bring that up is at the time, or it's I think still now apparently because this is still open, it's not supported in Mill. So what this would mean is if you're using Mill as a build server and you change your build.sc, even though Metals detects there's a change and it would prompt you to, like if you're using Bloop to re-import your build, it won't correctly prompt you to reload your build definition into Mill, because Mill is also a build server that reads everything into memory, not to disk. So this is you'd have to like you could use it with this without having this, but you would just need to remember that every time you change your build file, you would need to run it manually again. So yeah, so that's one issue that is still open, it looks like, but there is a PR. I think I looked at this a while back as well. Oh yeah, so it's like a huge refactoring to make this work the way that it should. Like there's a lot of work that gone into this. Which it was a few months ago, so I'm curious actually what the plan for this is, because it would be cool to get this finished, but let's look at the other ones. Diagnostics not cleared after successful compilation. Yeah, okay, yeah, it's pretty self-explanatory. The last time I tested this, like you would have a diagnostic, you would compile, and then it wouldn't actually clear the diagnostic, which is kind of annoying. So that's still open. Yeah, so again, I think that this alone, for example, would make it unusable for me. Like I wouldn't want diagnostics sticking around. This one's closed, which is cool. Yeah, so compile notifications are something that Metal uses pretty heavily, I would say, and what it is like when you send in a compilation request or send in a different request for a few different types of things, it will notify the client that it's finished with that thing. And this was just that it wasn't saying the task was finished, and this was a quick fix and looks like it's fixed and done. So that's cool. This one's also finished as well. So this was the incorrect range and diagnostic, which I actually believe there's something still related to this that's not working as expected. Yeah, exactly. Oh, yeah, okay. Actually don't know what's wrong with this. I have a comment here. Hold on. The range. Okay. Yeah, so like the thing that still exists that is still a little bit of an issue in this case is yeah, you'll notice that like this is what the diagnostics look like coming back from the build server, and the range here, for example, is 15 to 19. So you would expect this entire thing, the entire like identifier to be underlined, which it still is in this case. But actually, like the diagnostic range that Mill is giving back is just one single. It's nothing. It's just this one character. So you wouldn't actually like that should change, but that's probably not a huge blocker because it does seem to actually be working. But yeah, let's try this out, because I want to just verify that these things are still there, if they are, and we can try to, yeah, I don't know, send in some more issues, or just figure out what's going on and what the state of it is. I like do not remember at all actually how to even run this. It's a Mill command that I do not remember. Ooh, Mill got a new site. Nice. This is way better than what it used to be. Oh, nice. Cool. This is really great. I'm pretty so BSP, the way it works in Mill, I'm pretty sure is that it's a contrib module. Yeah, so build server protocol. Yeah, so the contrib BSP module is now included by Mill by default. Run the following command in the working directory of your project to generate a BSP config. All right, so let's try this out. So we should be able to go back to here. And again, keep in mind, we do have a .bsp directory already. And, whoops, I don't know why I tried to do that. I knew this wasn't going to work. What am I trying to do here? I think I'm trying to do tree, but apparently I can't type. Ugh, level 3. Yeah, okay, whatever. So, get out of lib. Maybe that's the problem. Go into BSP, and you'll see, oh, geez, BSP. You'll see that we have one entry in here, an spt.json file. And I would expect that after we run this mill command that we would then have a mill.json file that's going to be in here as well, right? So let's try to paste this command without the bashisms and see what happens. Actually, I'm not 100% sure what version of Mill I'm even using or anything like that. So maybe that's, what is the latest version of Mill? This. Or 9.6. How do I copy this version? That's annoying. Okay, let's see. Ah, there we go. Okay, so it did generate it, it looks like. So let's take a look inside of here then. So .bsp. Yeah, exactly. Okay, so cool. So we have this mill.json file here now. And as you can see, it has a name, right? Mill BSP. And then this is the argument that it needs to create, to start the server actually, which is what we saw in the BSP one as well. Oh, okay, and this one knows how to handle Scala and Java. Oh, I'm actually curious why the SPT one didn't say Java as well, because you can compile Java code with SPT. So yeah, this has 2.0 of BSP, where, oops, I want to say the SPT one was newer. Yeah, so they're not on the same BSP version, so, well, M5. Okay, so anyways, that should be fine. But I actually want to ensure that I'm doing this with the latest one, so with the latest version of Mill, just to make sure I get all like the fixes that might be there. So let's, what are we on? 9.6. So let's copy this again. I want to assume that this is all I need to do. Go like this, and then I can do, instead of doing this, try this and see what happens. Okay, cool. So, oh, it's still compiling. The BSP connection JSON file probably already exists, will be overwritten. That's fine. So let's take a look at what it created just to see if it's the same thing or not, if there's any changes, or if the BSP version is. So it actually, the args look a little bit different. Yeah, because remember last time it was actually pointing towards some Coursier stuff? Oh, it's probably because I have Mill downloaded with Coursier, and instead I'm actually using the Mill that's inside of this directory. Oh no, so same BSP version. Everything else looks pretty much the same. So, all right, so like I said, let's open this project back up now. And what should happen is that first it will default to Bloop like it always does. Like nothing will change there. It's pretty small. Let me make this a little bit bigger. Everything's indexing, should be fine. And again, let's go to Metals Doctor, because I think I'm using SPT at the moment as well. So we'll do a couple. Oh no, I'm using Mill. Okay. So build definition is coming from Mill. The build server we're currently using is Bloop, which is, like I said, to be expected. But now, if we do a Metals BSP switch, we should see Mill as an option. Boom, yeah. So like I said, if it's in a build tool that Metals knows about, you see the Bloop one by default, which is what we're currently using. It will then pick up everything that's in the BSP directory. That process is actually called BSP discovery. So it sees that there's an entry for SPT. It sees that there's an entry for Mill BSP. And yeah, so let's try to connect to Mill BSP. I'm actually going to split and tail the Metals logs, because I'm curious just to see if there's anything that, I don't know, yells or complains or something. So let's do this. Hey, thanks for the bits, Agile Steel. How are you doing today? All right, so I'm actually not seeing a whole bunch of feedback. No build target. Well, that's not what I want to see. All right, let's check actually. Metals Doctor. Oh no, it still thinks I'm using Bloop for some reason. So let's try BSP switch again. Oh, maybe I just didn't hit it right last time. I don't know what the deal was. Yeah, I am doing pretty good. Doing pretty good. It's been a pretty chill Saturday. It's been pretty sunny today, and like normally in the Netherlands, it's like just rainy and cloudy every day. So it's really nice to like walk around outside, get some fresh air, get some sunshine. And then tonight I just wanted to like look into some BSP related stuff, and I haven't looked at this in a while. So yeah, I was curious. So I'm doing good. Thanks for asking. So yeah, so it looks like the build is importing just fine with Mill, which is to be expected, hopefully. Maybe not. Select more info to learn about this problem. All right, so let's do that. Let's just do more info. Oh, does more info not work when I select that? Anyways, let's go to Metals Doctor. it's an issue for another day. Okay, so now when we look at Doctor, we can see that, yeah, we're using a build definition that's coming from Mill, and we're also using a build server, which is Mill BSP. So right away off the bat, it knows, yeah, how to do that. The find references thing, that's a little interesting to me, like why this is, like why that's the only thing that it's complaining. And here's like one of the tricky parts, right? Like I showed you some things that weren't working for Mill BSP, and one of them was the workspace reload. So when it says run import build, it's actually like what this will do, Metals build import. Remember I was saying like some of the language that we have is like very Bloop specific, when that's not 100% the actual like thing that it's doing. So build import here, if it's using Bloop, will run a Bloop install, like a build import. But if you're using, like I said, a server that reads stuff into memory, it will run a workspace reload. So when I trigger this, you'll see here correctly reloaded workspace. But the thing is that it didn't. Like this is a little bit deceiving because I'm pretty sure there was a request sent, but nothing happened. We can actually verify this. Let's verify this. So if I do tail LSP, which will tail all of the LSP communication, what we can do here is literally see this request, right? So like here's a save request. You see a bunch of jazz that's going, and we'll do a Metals build import. And what this should do is send a workspace reload. Actually, no, I need to do a BSP trace for this. Sorry. Tail BSP. All right. So what you should expect to see here is a workspace reload request. Maybe. Okay. So let's jump back up here. All right, so sending request for Scala main classes. I'm not sure why that's the first one. Scala test classes, that's all to be expected, I guess. Interesting. So I don't actually see it, and I don't know why we don't see it, because that should, in theory, be like the first thing, or like the only thing that's really happening. And it could potentially be that like Metals is detecting that whatever build server we're using here doesn't actually support workspace reload, and therefore it doesn't trigger it. I'm a little bit curious about that. So we can actually check this out as well. Let's see if I'm on the latest. Push this up. Yeah, let's actually like look into Metals to see like where this is happening, and I'm curious to see like what just happened there and like why it said successful when it's like really not. So I'm pretty sure we'll have to find where this request comes in. Actually, it should be by the commands. So search for workspace reload. Huh, that's not what I was expecting. Reload workspace. Actually, while this is like indexing, we'll jump back over here and try this one more time just to make sure it wasn't a fluke. All right, so let's try this again. Metals build import. Yeah, and you actually don't see anything happen this time, which is interesting. Which again, I wouldn't expect. But okay, so like that's one issue maybe is like the reload stuff, and where this like really matters is if we're here, right, and we're trying to change this to 213, we save, that should have triggered a workspace reload, but it didn't even notify us of that, so that's a little bit funky. I don't know why that didn't work, but whoops. Let's see where Metals is at. Still doing a Bloop install. But let's test out some of this other stuff. So one of the other things, right, was the diagnostics not being cleared out. So let's try that. So let's say we have val x, which is a string, and we assign this to 3, which should give us a diagnostic from nil. Compiling main. Yeah, okay, so main compile failed. It's actually really interesting. I think there's something different going on with how they send messages as well, because this actually shouldn't show up here, because this is sending a log message even though I have status enabled, so it should have been there. I don't know, it's something completely different, but that'd be something to look at if we were going to like offer support, better support for this. So here is the diagnostic that we have, right? We found an int, we wanted a string, so like it used to be that if you change this and saved, it wouldn't actually clear the diagnostic. Compiling main, compiled main, successful. Yeah, so this is the issue that I would say like makes it unusable for me, is like I just fixed this and it's not clearing the diagnostic. So that still exists, which is kind of a bummer, but whatever. So let's go back to where the list was. So workspace reload. I mean, I'm assuming that if, yeah, this isn't supported because it's literally... Actually, what was this PR? Did this PR do something with workspace reload? Nope. Nope. Okay. Let's close this. So yeah, so this still exists. What is the actual problem here? Did I actually find what the issue was? Okay, so yeah, so after you clear the diagnostics, you get another published diagnostics with, I'm assuming, an empty array of diagnostics, so it knows that there's no, or actually, I think there's a reset true that may be on published diagnostics, and that will reset it. Oh yeah, exactly. As you can see, the task was sent in. There is a bit of progress on status code 1. However, there wasn't a build published diagnostics with reset to clear out the previous diagnostics. So that's what it's missing. Okay, so that still exists. What were the other ones? Just to make sure. So these two are completed, and oh, so these are the two. So reload and diagnostics not being cleared. So yeah, it doesn't look like these are fixed, but to be honest, like, if these two were fixed, we would put into work and literally make Mill like a first-class citizen in Metals, like as a build server, the same way that we do SPT. Because right now, like, so let's switch back to Bloop. Switch back to Bloop. If we delete this, so let's go into here. And oh, there's a mill.log inside of there as well. I guess I wouldn't have expected this to be in here. Let's see if there's any reload requests. Nope. Workspace reload. Yeah, nothing. All right, that's fine. But yeah, so like if there, whoops. If there was this gone, so let's delete this. Let's delete that. So the bummer is that, like, if you were going to like now want to use Mill as your build server, you would have to do the whole manual like Mill BSP install again one more time, and that would create it. And every time that you would change your build definition, you would need to do this again, right? So ideally, what would happen in this case is, because Metals knows what Mill is as a build tool, we would be able to just do the same thing as we did with SPT, right? Metals generate BSP config, and then it would detect that it's using Mill because it knows about Mill. It would detect that Mill could be a build server, and then it would auto-generate the Mill BSP, or like the mill.json file for the BSP connection, and then it would automatically switch to it. And that type of connection, or like that type of integration, is the same exact thing that we have when we're doing SPT, right? So like we're using, I think, still Mill, right? So yeah, we have Mill coming from a Mill on Bloop. So we'll switch, we'll do a reset choice without the tilde. Reset the build to, let's go back to SPT, and now I'll go back to SPT. So yeah, so it looks like, to be honest, like it's in the same state that it was whenever I wrote these issues. Well, minus those two. So yeah, this is something cool that I think honestly, if I knew more about Mill, this would be a cool thing to work on, because I do think this would be really cool to have as an option. So that's Mill BSP. But yeah, it goes to show like how you can switch between Mill and SPT as your build tool and as your build server as well. Actually, I think this is really cool, like how in this one directory, like this one Scala project, you can switch between SPT as your build definition or Mill as your build definition, Bloop as your build server, SPT as your build server, or Mill as your build server. Like there's a lot of combinations. Like I don't think there's a lot of appreciation there for like how much stuff is actually going on to make all of that work, and it works pretty well. So yeah, so that'd be cool to get that taken care of. But let's go back to Metals, and I want to see like why it said workspace reload when I don't think it was trying to. So let's go back to here. Yeah, I want to find like where the actual request comes in right here. Okay, so yeah, where I'm at right now is like we have an execute command. So the way that the workspace reload works is that we send in a workspace execute command build imports, or import build rather, which is this, which you can see here is just a build import. That's all the command is. And once we do that, we do slow connect to build server. Yeah, so we look to see if it's a supported build tool. And so like in the case that we were in, it knew it was Mill. We see if we have chosen a specific server in the past. So the reason we do this is like we want to remember, like if you're in a workspace that we default to Bloop most of the time, right? Unless you've made an explicit choice previously to use SPT as your build server, then the next time you open this project, you don't want it to default back to Bloop. So like that's what this is doing here. So is Blooper empty? The same thing. So I actually don't think we do a check for does the build server support workspace reload, because I want to say that that was actually something more recently added as well to the protocol itself. Whoops. Because it was something. Or maybe I'm just like assuming that it was recently added. Oops. Workspace reload. Oh, so it was the end of 2020, so. Okay. So yeah, it wasn't added an incredibly long time ago, but it was added when SPT became a build server. So yeah, let's see where this call actually is, because I am a little bit curious again. So here we go. So session is a BSP session, and we call workspace reload. Connection workspace reload. Okay, so this is what I was talking about, and this is where I was expecting to be like warned about is the initial connection, the capabilities. If it can reload, then we call workspace reload. If not, we warn and we just say future successful. So this is where I would have expected this to fall into when we were using Mill. Yeah, because it doesn't support workspace reload. Yeah, so I was just curious how that works. But let's try to look at Bazel for a little bit then, because yeah, that's the Mill stuff. I don't actually think I even have a Bazel project. Nope. So I've literally never tried this before. So let's find a Bazel Scala project, and let's try to see if we can get this Bazel BSP to work with Metals or not. So Scala Bazel example. I don't think there is a Gitter template for this. That'd be pretty awesome if there was. Metals new Scala project. Gotta wait. There we go. Discover more. Bazel. Maybe? Yeah, I don't actually know how like common it is for just like an average Scala developer to be using Bazel. So I don't know if there would be like even Gitter templates for this. Yeah, it doesn't look so. Never mind. All right, so let's try to find one. Bazel Scala example. Oof, this is from 4 years ago. So let's try to not use one from 4 years ago. Smaller one. Also from multiple years ago. Bazel Depths. Does anybody know of an open source project that uses Bazel that is a Scala project? That would be awesome. No, I was hoping that one of these would have like a linked test project or something. Bazel Scala. Maybe if I just search for a build file and then select Scala. Code. No, I don't think that's gonna work well. Scala. Search. We might just have to use one of the really old ones if we can't find a new one. There has to be a newer example. Scala Bazel. This one was updated more recently. Bazel Scala example. Oh, well, never mind. 2018. This is one we just looked at. Whatever, we should just try one. Let's try this. Do I even have Bazel installed? I do. Bazel Scala example. All right, so let's run the tests. No. Error loading package. Extension file Scala. Scala.bazel has errors. Build did not complete successfully. I don't really want to start with a project that's not working because that would suck. So let's look at some more options. Boom. Yeah, maybe I was hoping that this would. I probably should have spent some time before starting to try to actually find an example of one that was working. Easily convert SPT projects to Bazel workspaces, which is archived as well. Spark Bazel. SPT Bazel. Ah, what about this one? Bazel multi-version. Ah, okay, cool. This is a newer one, it looks like. Well, from Twitter, so yeah, let's try this. So let's get rid of this old one, clone this. Go into Bazel multi-version. All right. Step 1, clone the repo. Step 2, build and run code with different versions of Guava. Oh, this also has SPT though. But we're going into multi-version example, I believe. Yeah, okay, let's try that. Multi-version example. All right, so let's just try this out in this actual workspace right here, just to see. If this doesn't work, we'll like quit probably and just work on some other stuff. But I'm definitely very curious to see if this will work. If not, I'll put some more time into actually like finding an actual repo that will work with this. So let's try this. Yeah, so if you're not familiar with what Coursier is doing here, Coursier launch is literally like downloading what it needs to run this dependency, the Bazel BSP one. Then it's actually like launching it and doing what it needs to do with this main method. So it's calling this main method. So if this did work, it should have created a BSP directory, which it did. BSP. Yeah, and now we have a Bazel BSP .json file. So if we look in here, ooh, they even formatted it. Nice. Okay, so yeah, so we have a name, which we were expecting. We have some args, which is information on how to start the Bazel server. We have a version of Bazel, which is 000. This isn't what it's supposed to be probably. And it's using 200, and it can handle Scala, Java, and Kotlin, which is kind of cool. So if my assumption is correct, we may be able to just literally open up this workspace, navigate to a Scala file. So let's just go to anything inside of here. Cross build. Metals should be started. But it detects that it's an SPT workspace because there is a build.spt. Actually, so the bummer is that it's detecting the workspace root is right here, which is not what we want. We don't, yeah. So like you can see the .metals directory was created here, which we don't want that. So we need to like cheat this somehow. So let's actually not import this. Go back to here. Let's delete the metals directory because we don't want to pretend. I think for the time being, what I'm going to do is I'm literally just going to, in this example, I'm just going to like create a build.spt file just so it correctly recognizes that this is the root. And I'm going to go back one version and remove the build.spt file from here, because the logic that NeoVim Metals has is that it will look for a build.spt file. If it finds a build.spt file before it determines that that's the workspace root, it will look one layer deeper to see if there is another build file. And if there is a build file there, then it assumes that it's in a project with nested build files, and it will call that one the root. So like we're going to remove this one just so it doesn't think it's like a nested project. Go into the example. Now if I open this, it should think that this is the root because there's a build.spt. So let's open this up, go to a Scala file. Hopefully this will do what I'm expecting, and it will create this in this directory, maybe. Dang it, still don't think it did. Oh, because I'm in the wrong one. So let's go back into example. Yeah, there we go, bingo. So yeah, so now now it's created a metals directory, so it recognizes the correct workspace root. And we're just gonna like ignore the import, say like don't do this right now. It thinks we're using Bloop. It may have even created a Bloop directory, to be honest. Oh no, it didn't, which is fine. It could, it does have a Bazel BSP. What is Bazel BSP in this? Let's go up a couple of levels. I don't know what's actually in here. No idea. Pretty sure this is Groovy as well, right? Okay, so whatever. We'll just ignore that for the time being. Let's close this, open this back up, go back to our cross, whatever. But the thing I want to try now is that if I do a metals doctor, I don't think it will actually show us that we're even using a build server. Yeah, it'll say build server currently being used is Bloop because that's what it defaults to. It doesn't know any better, but really like nothing is being used at this point because like it hasn't picked up anything. So we are not going to use Bloop. I'm still just curious if it will create a Bloop directory or not, which it hasn't yet, which is to be expected, hopefully. But now the thing is, if we do a metals BSP switch, exactly. So it shouldn't, it actually, my apology. It should show Bloop because it fake thinks it's a or an SPT workspace because I created the build.spt file there, even though this isn't an SPT workspace. But then it also recognizes that Bazel BSP is there because it thinks that Bazel, well, it sees the BSP Bazel BSP.json file. So if we select this, in theory, it should start up the Bazel build server. So let's tail metals here to see what kind of happens. We'll select 2, attempted to connect to build server, starting local Bazel server and connecting to it, and connected to the server. So now we're getting some information back here, importing the build. This actually looks to be okay. See how long this takes. It's not a huge project, so it should be fairly quick. I'm gonna be so happy if I like try to do hover on this and it just like works. Yeah, I don't know enough about Bazel to know like what it's all actually doing right now. Analyzing 3 targets, 21 package loaded, 229 targets configured. Yeah, like I don't know like what the dependency tree looks like, so I don't know if it's trying to like compile a whole bunch of other stuff as well, or now we have an issue. BSP connection failed at the attempt to get Scala C options result. Protocol message has invalid UTF-8. All right, so we did have some action, right? Like it started up and then died. Nothing should work now, right? Like if I try to do a hover, it's not gonna work. It's kind of a bummer, but yeah, let's take a look at like what actually happened here. Disconnected from the Bazel BSP session. Failed to connect with the build server. No functionality will work. So it failed in the attempt to get Scala C options result. What could potentially have happened is that it doesn't support that yet. Like I have no idea like what it actually supports. So let's try to see if it supports even getting Scala C options at the moment. There's 2 issues. I don't know, so it should actually work. Test for build Scala C options. All right. I just want to make sure that there's actually like not a already build target Scala C options are returning empty. Ooh, is this what we're hitting on right now? After working on extending yeah, so we can try to test this, right? Like we can try to figure out if this is where it's happening or not. So let's split this. We'll tail the BSP specific logs and we'll try to manually connect to the build server again. So like what we were doing before was like doing a build import and like starting it out fresh. There's also like a metals build connect, which should trigger the connection again. So we should see like an initialize here happen. So yeah, so we have a build initialize, some information about metals because like metals is the one that's initializing the connection. Build initialize. Yeah, let's see like where it actually craps out on us. Received response from build CL. Yeah, okay. Received response. So like this is metals receiving the response. Build target Scala C options. Result null. Error code. Message protocol had invalid UTF-8. That's actually a little bit surprising because if I'm understanding this correctly, this is Bazel saying that we were sending in something that had invalid UTF-8, which I wouldn't have expected. So sending request, yeah, so this is Metals sending the request for the build target Scala C options for the targets that we want. Again, I like, so these seem to be all the build targets in the workspace, in that workspace that it wants. Sending request. Need version 1, needs version 3. I wouldn't have expected these URIs to actually look like this. Tricky user source main. So something, this is like what's going wrong. Like this is what's going awry. Is it like something in there is not great, like not working well. Because it thinks that it's invalid UTF-8. but the build actually completes successfully. So like if it wasn't sending in the request for the Scala C options and getting this code back, I actually think it would work. I'm curious about these URIs to see if that's what it looks like in other workspaces as well. So let's do a little test. So let's get out of here. Let's close out of here. Let's jump back to like an SBT one. We're gonna tail the LSP logs up here. We're gonna tail the BSP logs down here, and let's see what happens when we request stuff. So yeah, so here's the build initialize. We don't want all this. What we want is the request for Scala C options. So this is what I would expect with the URI. See how these like are actually like full URIs, like file, users, whatever. So that's why I'm like weirded out a little bit by the way that they had them formatted previously. And maybe that's the actual issue. Is it's not a UTF-8 issue. It might be like a file URI issue. So exactly. So this looks very different than what I was expecting. So here's the same request, sending request build target Scala C options, and we give like an absolute URI of where the build target is, and then we get back the Scala C options. But when we tried in that Bazel build, these were quite a bit differently. But I also don't know, like, it seems like this repo is like kind of like a test repo for multi-version stuff. Yeah, so I'm curious maybe if Twitter has a different repo that's public that uses Bazel, that's maybe just like more straightforward, just like a straightforward build. This uses build.sbt, so probably not. I'm assuming bijection is the same thing, probably uses build.sbt. Does everything? Yep. Come on. Nope. I know that they are switching over to Bazel, and I wonder if it's just like their giant, large internal stuff that's using Bazel, but all of their open source stuff just uses SBT. Twitter server. Also using SBT. Yeah, so I'm still curious to see whether this works or not, or to see like whether because my assumption again is that like there's actually not a whole lot needed on the metal side, that if this would like correctly finish the initialization process, there wouldn't be a whole lot of work apart from like detecting like build files from Bazel when detecting a change that's happening in a build file, and then reloading the workspace after that. So yeah, this was like a good first test, I would say, of I don't know how this would work with metals. I also I'm pretty unfamiliar with what's actually inside of this Bazel BSP directory and how that impacts things, and like what the server needs like out of there. But at the same time, like Bloop also needs a .bloop directory, so it might not be that crazy to need something else. So all right, so that's interesting. Does anybody have any questions about like BSP related stuff? I mean, we looked at a bunch of stuff in a like fairly short amount of time. I would say like an hour. We went over Bloop, SBT, Mill, a little bit of Bazel stuff. It's interesting to see how it's cool to see more implementations of the build server protocol happening. Because I think I'll try that out again later. I'll spend some time trying to like find an actual Scala project that is a Bazel build, or even just make one myself, like a really minimal one, and try this out again to see if we can mimic it. So we looked through all this stuff. I'd say check that off. We did that. Looked at all these. I'm going to take a very short break to use the restroom, and then we'll come back and we'll think of something else to work on, because there's definitely stuff. I think what I am going to work on or spend a little time doing is that I've recently been working on a new project, which has to do with NeoVim and Coursier and using it internally. And I'll come back and I'll tell you what the name of it is, and I'll show you where I'm at so far with it, and we can start hacking on that. So give me like a minute or two, and I will be right back. All right, so something that I've been working on recently is a new project. It's not super bunch of stuff. Welcome back. Does organize imports work for you? It worked in COC but stopped when I switched to native LSP. Yep, it definitely should work. What kind of issues are you having, Agile? I'll show you that it should work. So like if we jump to metals, I don't know, we go to like anything. Let's go to debug provider or something. Yeah, so like here we have like a pretty large, well, not huge file, like 500 lines. Let's mix some of these up. Put a couple of dumb spaces up here. And take these and stick them way down here. Yeah, so it should work pretty much exactly the same as it did with COC. But instead of doing like the, I think, space A and then source organize imports, you'll use the metals organize imports, which you should see now everything's, didn't work. Oh yeah, it's still going, hold on. Give it a second. Actually don't know why. Tail metals. All right, let's try one more time. Metals, organize imports, because I believe it actually just timed out. So my answer before was yes, it should absolutely work, but doesn't seem to be the case. So there, it does work now. Actually, I don't know what happened, like why it took so long. I have a inkling that it was timing out. Like if we look at, I think if I look at the NeoVim metals logs, actually, metals info, cache NeoVim metals. Okay, I always forget where it's located. So let's go to the root, cache NeoVim metals, tail NeoVim metals log. No, I don't see anything in there. Yeah, You're not the first person that has told me that it hasn't been working correctly in NeoVim metals. I don't know why, to be honest, or like I haven't been able to like pinpoint something that may be going wrong. But I normally like don't have, like this time is literally one of the first times I've ever had issues with it. I'm gonna like compile and save again, and then we'll reorder, just because that was really weird to me. Like, so like, whoops, let's do this. So we're out of order again. Save. Yeah, if you, I mean, obviously if you try to do it without saving, you're gonna get warned. Sort import should, if it doesn't compile. That's a good question. You can kind of assume that if, yeah, so like this time it worked. You can kind of assume that like if your code can't compile, well, I was gonna say anything that relies on semantic DB is not gonna work correctly, more or less. But then that might also not be like 100% clear to people what that is. So yeah. If there is, I actually don't know how that works with organized imports, to be honest. Let's try a minimal. Let's try a minimal example. I'm pretty sure organized imports does tell you though that you have a workspace error. Let's see if you're lying or not, because I'm pretty sure. I thought it did for sure. Scala. We can test. We can test. New Scala file. We're just gonna make it a package object. And we're gonna say val my value, which is a string, equals hi. Go back to hello and let's get rid of this. Get rid of that. Hi. Oh, what was it called? My value. My value. I'm pretty sure organized imports is a semantic Scala fix rule, so it needs compilation. Yep, exactly, it is a semantic one. So it needs compilation for it needs semantic DB for that file to be like very clear. So like we have imports Java time instance and import Java time clock. Oops. Yeah, so let's have these two in a very like minimal fashion. So like it should trigger here, right? Like metals, organized imports. Boom. So it flips them. But what happens if we have something in here that doesn't compile, right? So like val a int equals what? So like here we have a compilation issue in here. Let's jump back to this file. I'm pretty sure it will warn you. Metals, organize imports. Stale semantic DB. Maybe let it finish and compile. I've actually never seen that error either. That's the thing. Sometimes there's an error, it's message, and sometimes not. Metals, organize imports. So I've actually was always curious when this message will be showed, but I'm pretty sure what's happening behind the scenes right now, and like I'm very curious like for you to have a situation where you don't get an error message, and if you can reproduce it all, those are like incredibly helpful to try to debug this stuff. But like in this scenario, there were changes made in the workspace. This file produced semantic DB before, but now it's not producing new semantic DB, so it knows the current semantic DB is stale, and therefore it won't run the organized imports. I see a semantic or stale semantic DB from time to time, and usually it's when S doesn't compile somewhere else. Yeah, I've been thinking a little bit, because I watched your video that you shared the other day, Agile, and about like debugging metals issues and what happens when you have a like some other related module has like an issue and it's actually causing issues in your current module and you don't necessarily know about it. Yeah, it's to be fully frank, I think one of the biggest issues with that type of thing is in my mind, I'm like, well, of course, like it didn't cascade compile, so like it's not going to catch that issue. Or, oh, of course, you have like a little, like on the bottom left, you have like a little like exclamation mark saying like 1 issue or 10 issues. That's really obvious, but it's not really obvious to people. And I think I'm just so used to like using metals, and not even just using metals, but like working on metals, that those types of things are very like clear to me why something may not be working. So I know to look for it right away. Where for like an average user, they don't care, and they shouldn't care. Like it should be incredibly obvious to them what's going wrong and how they should fix it. So yeah, I understand that. But in this situation, like maybe this is a good question. Is this a useful error message? Like stale semantic DB? Like does a user know what to do in this case? Like, oh, stale semantic DB, what does that mean? How do I fix that? Because as you can see, like at least on this screen, it shows that it compiled. It doesn't show me any warnings that there's an issue in my workspace. Unless I go like this, then I do see, oh, there's an issue over here in package.scala. So I guess in my head, like if I would see a stale semantic DB error, like warning message, I would know to look at my workspace diagnostics to see if there is an issue somewhere, which there is, right? So get rid of this, jump back, do metals, organize imports, and now it works. But yeah, I'm probably not an average user, but I'm guessing an average user has no idea what semantic DB is. Yeah, that's true. Yeah, we could change it. I mean, we can change this error message. Scala fix provider, stale. I'm not even sure if that message is coming from metals or if we're just literally like passing it along from Scala fix. Stale. What is the exact message? Actually, let's split this again. Here you had me thinking I was gonna go work on something else, and then we find this. All right, so int. It's funny that you're like talking about like semantic rules and Scala fix, because I tried to do something earlier today that I was really excited about, and I totally forgot that it like wasn't easy to do because it was a semantic rule. I'll show you what it was in a little bit, but okay. So yeah, so like let's say organize imports. Yeah, see, now this time it works. How does that? I don't even understand this. Metals, organize imports. I'm going crazy here. This shouldn't even work. Okay, let's try to like reproduce exactly how we did it before. So there's no workspace issues, all gone. We can swap these around, do metals organize imports. It will work. Boom, it works. Save this, jump back over here. Say that we have a val a, which is a type int, which is not int. Save, get a diagnostic, go back over here, try to organize imports. Okay, stale semantic DB. Now we get the message, right? Stale semantic DB. Oh, it actually has like more information too. What? It even tells you where it is. Why does it even give us this? I'm gonna argue like a user never literally wants to see this. Tail LSP. Where is this coming from? Metals organize imports. So it's coming straight from Scala fix, I'm pretty sure. Message, stale semantic DB. Am I like incorrect in assuming that like nobody cares about this, that we shouldn't show this to the user, the like thing? If I were you, I'd stay away from package objects when trying to reproduce. In the past, they used to create a lot of headaches for the incremental compiler. Yeah, that's also true. Yeah, but I can reproduce it somewhat easily. At least we have it now. So, but yeah, am I incorrect in assuming like the user probably doesn't want to know that the stale semantic DB difference between hello Scala on disk MD5 fingerprint is different than the MD5 fingerprints with this hash. Yeah, so let's actually see like where this is coming from, because stale semantic DB is not, I'm pretty sure we probably catch an exception from somewhere. Or where do we actually call this? If Scala fix succeeded, Scala fix error, get message from Scala fix. Yeah, so I'm pretty sure that like this is where it's coming from right here, right? Like get error message from Scala fix. Yeah, I don't know. Like I might just like create an issue for this to like discuss it with some of the other maintainers, because I don't actually, because if we like, it's useful, right? Like it's useful to know that this is a stale semantic DB error. So maybe like a better thing to do would be like, instead of just like doing a pass through here, to probably do like, is it a better idea to just collect on the failures and show a nicer message? Because yeah, because I don't think that's a useful message. What's up, Jengtron? Thanks for the follow. We could also try to like look into Scala fix to see where that's coming from. So if we do, I think I have Scala fix locally. Scala fix, Mill Scala fix. Do I not have Scala fix? It's not in Scala Meta. Yeah, I don't think I actually have it locally. Let's clone it down. Scala fix. No, it's okay. I would rather work on stuff that's actually bugging people agile, or that could help like somebody, I don't know, that could help like lessen the confusion of metals, than just some like random whim thing that I want to work on. Plus you gave me bits, so I gotta do what you want. Git clone. E.g. stale semantic DB. Oh, that's a big search. Hold on. Let's go into Scala fix first. E.g. So stale semantic DB error. All right, let's try to look at that, because I'm pretty sure that's the error that we're seeing, and we probably don't want to fully see it. I'll code for bits. Yeah, that's my new MO. You got an issue? I'll code for bits. Scala fix. All right, so let's import this thing. Actually, I haven't looked at the Scala fix code base in quite some time. I mean, I haven't worked on Scala fix hardly at all ever. Okay, so what exceptions do we have in here? Do we have any exceptions that we have? No, not right. Or actually, let's just try this. Let's just see if it is like will be imported. Stale. Wishful thinking. I was hoping I could like just import it and see what it is. Scala fix runtime exception. Okay, let's see if there's actually stale semantic DB exception. Scale. These actually might not even be coming from Scala, or maybe. I just saw this message about this like being in Scala format and some of these errors being similar. Oh no, sorry. I don't even know what I'm thinking about. This has to do with formatting. Never mind. I was like, oh, Scala format had an issue with these at rel? Like, no, it's formatting. Never mind. But this isn't what I wanted, so let's see where this is. Exit status. parse exception. Yeah, I don't know like which of this stuff is coming from semantic or from Scala Meta directly, and which of it is actually being produced by Scala Fix. So let's wait to see for this to like import, and then we'll see where this is coming from. But while that's importing, what I was going to show you before Agile derailed me was something I've been working on. I worked on it on Wednesday stream. Something that's pretty cool, I think. Wow, that is taking so long to find. I used to, before I started using Telescope, I just like pretty much like only used find to find files and to navigate to them. And now I just think I'm insane that I used to do that because it's so slow. Look at this, it's like hanging. It's still good in like very small spaces, I guess, if you know exactly what you're searching for, but I mean, this is useless. Look how much faster this is. Oh, gravy, nice. Okay, so what I've been working on is like when you're on a dependency like this, you just go bump, bump, bump. And behind the scenes, it uses Coursier. And here we see that we're on the latest one, right? We see 113.1, so we know that we're on the latest of this, right? Let's check this one out. Boom. Here, there's multiple options. So like it's not semantic, so like don't be fooled and think like behind the scenes like there's like really intelligent things going on. Like when I do this on here, it recognizes, it can like parse that this is the organization and this is the artifact that it thinks it is. So it knows to like do a Coursier complete off those, but it doesn't know like what version you're using. So like we're in 2.12 here, and now it has the versions, so you can copy the version out. So I've been working on this a little bit, and I've been trying to clean it up, and I extracted it out into its own little plugin. And I have this idea that I'm naming Scala Welder because it's my hopefully clever name is that, yeah, it's going to like kind of like merge together utilities on top of metals together with metals for Scala and NeoVim. And I started with Coursier, and that's like what you're seeing here is all this stuff. And I think I still have a couple things to work on here, including like making this work correctly with Mill. Like, because right now, like the match that we do to get the artifact is SPT only. So I want to get this to work with Mill as well. We could even write some docs for this and like potentially like push it up and actually put it out into the world. But I wanted to actually try out what this would work, like to see if this would work with Scala Fix, and it totally doesn't. And like the thing that's kind of a bummer is that there is a Scala Fix command line tool, right? Like you can use Scala Fix CLI, but it will like, I don't know if you've ever looked at it before, like Scala Fix. Nope. If you only are going to be running syntactic checks with this, it would work pretty well, right? Like there's actually a flag that is, I think syntactic, I want to say. Yeah, syntactic, where it runs only the syntactic rules, even if you have semantic runs explicitly set in your scalafix.conf. So my clever idea was, oh, like it'd be so cool to just like in a single file get like explicit types. Like that's something I really want, but that's a semantic rule, right? And then if you try to use Scala Fix directly on a Scala file with a semantic rule, it'll tell you it can't find the semantic DB for that file. But then I was like, well, if you're using metals, we do have semantic DB for that file. But you also, then everything falls apart, like, because you need like the class path that, like, you need the full class path, or like their defaults to a class path. There's just so many things that you need to like actually hand in to Scala Fix. And trying to like find the correct semantic DB for this in like a Bloop directory would just be a nightmare. So I was pretty bummed out that I was sort of assuming that like, oh, this will work, this will be great, and like it totally wasn't great. It didn't work. So we're gonna delete that. That's not working. Like we're not gonna have a Scala Fix part of this. So I'm sad to delete that. Unable to delete directory. Why not? Probably because I have a buffer open in there still. Yep. All right. Whoops. Didn't need to do that. Wow. Importing Scala Fix is making everything slow. So let's delete this. And one thing, why can't I delete this? What is going on? So we remove Scala fix. Bye. All right, let's see if this is going back to Scala fix. We're still compiling. Let's see if we have enough to actually navigate to this. Oh, we do, maybe. Generate exit status. That's not what I was hoping for. Missing. Oh no, stale semantic DB is what I wanted anyways. Stale semantic DB error. Yeah, okay, so this is what we are seeing. So like the error message that you're seeing when you try to organize imports is like directly coming from Scala fix. Stale semantic DB and then this diff. This diff is kind of dumb to show to the user is what I should say, because we don't want to see this diff. So I think we should probably like match on the exceptions that we're getting from Scala fix instead, and then choose like what we use from the user. I'm not going to work on that tonight, but it's a good point. When you are unable to organize imports, at times the messages shown to the user are not really friendly. A prime example. All right, so let's just, I'm going to grab an example of this. I think, where was I? Here. Close this. Whoa, what is going on over there? Close this. Copy this. Yeah, like this isn't useful to the user, I don't think. Yeah, we definitely went down a rabbit hole on that one. Yeah, so yeah, I'm not gonna work on it right now. I mean, to be honest, going down a further rabbit hole would be like, let's fix this now, let's change all of this. But yeah, I don't really want to work on this right now. So, but yeah, I totally agree. Like showing the diff here to the user is just like, it's gonna cause more confusion anyways. Because like, what does this mean? What is the on disk MD5 fingerprint versus what is the semantic DB MD5? Like what and why? Like why does the user want to see the actual hash? Like, so thank you for pointing that out. We will get it fixed sometime. Maybe we'll even do it on stream like later next week or something. But yeah, good point. We'll fix it. We'll fix it. Prime example. Anything else that like isn't working for you with NeoVim battles that like is annoying? Because honestly, like sometimes not hearing about stuff is like the hardest thing, because like you don't know what to fix or like how to help users even figure this stuff out. So this is like a perfect example of something that, to be really honest, I've seen probably the stale semantic DB message before and just thought, oh, stale semantic DB, let me figure out what's going on, and never even like did a second thought about like how confusing this message actually is for the average user out there. All right, so whoops, let's work a little bit on what I'm calling Scala welder.neovim. And what I would like to maybe get done is, right now you can complete a line of SPT deps, but what about mill deps? Maybe we can look at that. And then I also want to do like a generic one where you prompt the user for input. Which arguably might be more useful than what we currently have. So let's go back to here. Let's get the workspace situated. Scala fix, I don't need anymore. I wonder how, like, the final thing on this, and then I'll move on. Like, I wonder how many more of these there actually are, like other extensions that, or other exceptions that like we do, because like it's a straight pass through in Metals. Like we are literally just like getting the message and then passing it along. And I'm curious like what other messages that Scala fix may give that aren't super nice to us, that we wouldn't want to show the user. Extends exception. Better RSC compat. Would this ever come to us? Missing symbol? No. Extends exception. Scala fix exception. Compiler exception. Maybe there's not that many actually. I don't know, whatever. We'll look at it later. Don't go down the rabbit hole. Okay, so let's get out of there. Let's go to the Lua workspace. I should maybe even change the stream info to not be BSP stuff anymore. So we're working on Scala NeoVim metals. We're gonna say Coursier in NeoVim. Done. I think that should update my title, maybe. All right, so we're working on Scala Welder. Let's jump to the Coursier file here, and let's figure out what we want to work on. So the first thing is we do this super greedy grab to figure out what the dependencies are here. Also, like, I don't know if any of you watched on Wednesday. I don't know enough Lua to know if this was stupid or if this was like the right thing to do. But so if you're a Lua expert out there, what am I looking for? NeoVim config NeoVim. When I first did this, I actually have two versions of this. On the right hand side, I just did this like in random functions, but it like felt kind of weird because I felt like we had this completion object table that we were like building upon, that we were like we had an organization and we had an artifact, and then we needed to like add to that artifact, like build upon it. And my head was like, I just want like a completion case class that like never gets mutated but like gets updated, and a couple functions to do that. Like I couldn't, like, it just didn't feel right the way that I did this the first time through, because yeah, like I have this like local state up here, and like I was just mutating the crap out of it every time, and like all these different functions were like mutating this thing, and I just, even though it's all contained inside of this one file, I just felt gross, and I was like, this doesn't feel right. And then this kind of seemed like a little bit appropriate to do with a meta table, but I was like unfamiliar with Lua meta tables, or like when to use them, when they were more appropriate. So I like completely rewrote this, and I don't know if this was a good idea or not. So like part of me is like, yes, I figured out how to use meta tables. So then part of me is just like, this is probably completely anti-patterned in Lua, but it seemed to work okay, because instead of like this like state that's being like mutated from all over the place, really the only thing that's ever mutated or like changed from different places is just like we have this ongoing compilation up here, or completion, which is, it starts out as nil. It's like not, and then once we do, the only thing that will actually be updated will be that this completion meta table will be assigned to this thing. And it's actually kind of cool. So I'll like maybe walk through how it works. And again, if this is like completely anti-pattern in Lua, whatever, it works. But yeah, we like grabbed, it's pretty simple how this all works. We grab the line from SPT, we get the organization and the artifact. We create this new completion here, like this, completion new. And you'll see like inside of this, we have index, which is how it's being called, like when it's new, I believe. We have some functions that are tied to it. So we have a compare completions. We have the complete function itself, which actually does the completion. Create window, which handles the window creation. Display, which handles setting like the buffer text. New, which is how we create a new one, as you're seeing here. Reverse, which actually reverses the completion ordering. I don't remember who actually recommended this last time, but somebody was like, it'd be really nice when you have the versions, like to reverse it. So like the newest one is on top, so that I do that with this, with reverse. And then I have this set key map thing. And the kind of cool thing is it allows you to like chain these kind of. So like you can do like, I have a completion and I want to complete it. And then I want to create the window, and then I want to set the display, and then I want to set the key map. So like it makes everything pretty succinct, and it's all done with this like completion meta table up here. So I don't know, I learned quite a bit doing this. I've never like used meta tables before. And again, I'll look back at this probably in like some time and be like, whoa, what was I doing? Yeah. So again, I don't know if it was worth like rewriting the entire thing to do it this way, but I think so. Like I think it's pretty good. So what do we want to work on? We can work on this to do, which is to handle these from Mill to get like IV depths instead of like the normal way SPT does. It shouldn't actually be that tricky to do. It should be pretty similar to the way that we do it here. Just changing the capture groups a little bit. The other thing that I think would be kind of cool is like right now, like if you're going to use this, that's actually a really bad example. Let's go back to BSP test maybe. Nope. Yeah, so I have one here. So yeah, you have to be on these, right? Like, and I think sometimes you might want to like know what the versions are without being on top of a version. Like, let's just say like you want to add MDoc here, and it would be cool to just like trigger something here that would show you a prompt that would allow you to say, I know I want MDoc. So like maybe you can give it as much as you want, right? Like you can say org Scala meta MDoc, and then complete, and then see what comes. And then maybe you'll see, oh, well then you need to choose 212 or 213 or M whatever. And then once you choose that, then you choose the next one, and then it will spit out to you this actually. It would actually like spit out this whole thing. So you can just boom, like you have this. So I think that would actually be more useful than just like checking what version this is here probably. So I want to figure that out. Oh, actually, I'm pretty sure I might have made even notes for this. No, in the project. Oh, yeah, okay. Yeah, so I was made this earlier. So Scala fix stuff, just see this if this will even work. No, like this won't work. Get rid of it. Create some docs, create some logs. Those are like general like housekeeping things we can look at later. Coursier stuff, detect mill dependencies, which is what I just talked about. Offering a generic completion starting from user input is what I just talked about. This one is like related to what I just talked about, where like you can copy the output. Looking to resolve. What I mean by that is like, let's say, actually let's jump back to here. Resolve is just like from the editor, I want to do CS resolve org Scala meta. Well, here I kind of have it all completed. Boom. And then you see all of this. So then you would actually like see all of this right in your editor, and you'd be able to, it's almost like SPT dependency tree, except you would see it in like a nice floating window. I don't know like what other types of functionality, because like this is like pretty long, right? So like it would just be in a giant floating window. I don't know how useful that would be, because often like what I personally use this for a lot is like I want to see where, I don't know, like what's using this, like what is using Java diff utils. And the way I typically do this is CS resolve the entire dependency, and then what depends on. Yeah, and then you can see, so like it's like MDoc is directly depending on this, so you can kind of see this. So maybe something like this would be kind of useful to do in the editor as well, but I have no idea like how that would actually look like inside of the plugin, so it's something we can play around with maybe. But let's pick something. So let's go back to here. Oh yeah, and is there a way to show the full completion in the window? That was another thing, because right now, right, like you don't know where you're at in like the completion itself. Like I know I would maybe like to see like on top that like we have org Scala meta MDoc so far, and this is just completing whatever we like where we're left off. But you never know really where you left off, so I don't know how useful that would be either. copied version. So that's something we can take a peek at. But actually, when I first looked at plenary jobs, which is what we're using for this, there was an example that actually used like user input. So I want to see if I can find that again to use as an example. So let's go back here. I'm going to search for plenary job. Search all of GitHub code. It's actually like really nice right now because there's not like an insane amount of people using this. So like when you actually do like a search like this, you get pretty useful stuff instead of just like thousands and thousands of results. Now I just need to find which one I was using. Prompt buffer, I think maybe this one. Actions. Oh no, this is actually from using Telescope as well. That's kind of cool. I should have saved what I was trying to do before, because I want an example for sure. Or maybe it was a window that I was, maybe that's what it was. I searched for window, plenary window float, and that's what gave me the example that I'm looking for. Oh, actually that makes way more sense. I'm pretty sure that is what it is. Lua. Window test. Yeah, thanks for stopping by, Aja. It was good to see you again. Try to find an example. Load. Yeah, I'm trying to find an example where somebody's actually using input inside of one of these that is created. Boom, boom. Ooh, prompt. Maybe this is what I was looking for. All right, I'm gonna turn my light on because it's starting to get dark. Give me 1 second. All right, so like this is actually pretty similar to what I'm looking to try to do is, so they create a plenary window just like I do here, and they set the buff type as a prompt. So yeah, let's try to like mimic some of this stuff here. Because the way that so the first thing that we'll try to work on a little bit is like the functionality that instead of just being on a line, you can also try to like just trigger at any time. So we'll probably just do this with like an entire new function. We'll just be like local, what is this other one? So complete from line, we'll just say complete. Like, yeah, this will just be called generic complete as a function. And what we'll do with this is instead of like starting from a specific word or something, we'll create a window right away. So let's find out where this other window is. Grab this, create that. So we'll create a new window, and then we'll do a Vim API NeoVim buff set option. Bum, bum. I think we could just do when buff number. I always forget like what this is in there. Buff type and prompt. All right, so like this should be literally be enough to like at least test to see that this is working. So then we'll return just the generic complete. Complete. Let's go to my init. Oh yeah. Init. Playgrounds. Yeah, so we'll copy this directly. Should probably actually start to like make real mappings for these. So we'll say these are Scala welder and Coursier complete from line. Let's get rid of the leader. So yeah, so like at least my like common thing that I do to like keep track of like which things are like playgroundy, like things that I'm screwing around with. Like in my like I have a directory called playground, so I just do leader is like everything that I'm just like screwing around with. Where like when I don't do that, it's like legit actual like stuff I'm trying to do. And I don't think I have any leaders C. Oh no, I do have some leaders code actions. So yeah, let's just do leader CC for Coursier complete, I guess. I don't know. Leader CC. And that'll be a complete from line. Oh no, actually, let's just do CC. Oh man, these are too long. No, let's do something totally different. What's a leader, or what's like a mapping I like do not use at all? Worksheet hover. Do I do leader S for anything? And I'll just put like all my Scala related things under leader S. I don't think so. Nope. Looks like that's the winner. Okay, so we'll do leader S complete line complete. We'll do that. Okay. Then we'll create another one and we'll just say Scala complete. And instead of complete from line, this will just be complete. We'll get rid of this guy. Yeah, this is the old one, so it's still in there. It'll still work. So let's try this out. So just to restart this once, so it actually will load up my init, and then we won't have to do this anymore. Okay, so SLC, boom. So like this one still works with the new mapping. Copied. And then the other one was just leader. Oh no, not. What was it? C. No. Leader SC. Boom. Okay, so now it's a prompt, right? So it does give you. I actually don't know how the prompt is even supposed to work, to be honest. So Scala C. Oh, you have to go into insert mode, right? I was kind of assuming it would bring you into insert mode. All right, let's check that out. NeoVim buff set option. Buff type. 0. Option name, option value. Buff type. Prompt. Buffer where only the last line can be edited, meaning to be used by a plugin. See the prompt buffer. Prompt buffer. Using a prompt buffer. If you want to type input for the job in a Vim window, you have a few options. Use a normal buffer and handle all possible commands yourself. This will be complicated since there are so many possible commands. Use a terminal window. This works well if what you type goes directly to the job and the job output is directly displayed in the window. Use a window with a prompt buffer. This works well when entering a line for the job in Vim while displaying possible filtered output from the job. A prompt buffer is creating by setting buff type to prompt. I've actually never used this before. The user can edit and enter one line of text at a time at the very last line of the buffer. When pressing enter in the prompt line, the callback set with prompt set callback is invoked. It will normally send the line to a job. Ah, okay, so like this will work pretty well, I'm pretty sure. So we'll have to figure out maybe how to go into insert mode automatically, because I don't know, that would annoy me, I think. But yeah, so we set it as a prompt. Can you set prompt? Okay, can you set the prompt to a specific thing? Set prompt. Set prompt. Maybe. NeoVim buff set prompt, maybe? Actually, what was it? I'll look at the other thing. Ah, prompt set prompt. All right. Actually, here, let's just copy all this stuff out. Or do some copy pasta from this person. And then we'll figure out what we don't need. All right. So let's comment this out for now. Okay, so we have prompt, set prompt. If I spell prompt right. Set prompt to buffer to text. You most likely want text to end in a space. All right. So Vim function prompt set prompt. Again, we'll give it the win buff number. So we should be able to do like CS complete. Something like this. Oh yeah, I don't even need to. What am I doing? I think I could just do this. Set prompt takes in a buffer and a text. Okay. So should be able to do oops, Scala complete. Nice. Okay. That's good. That's actually like quite a bit of text though. I don't know if I really want all that. That was a cool idea in the beginning, and then I realized it's taking up like a ton of stuff. What if I just do this? I don't know. Get me out of here. Scala complete. No. Yeah, okay, so maybe this is a little bit nicer. So then you would be like, oh, I want to complete scores, org, Scala, meta, mdoc, boom. And then that should call the callback to try to complete this. And then we would just close that window and then open the other window that we were working with before that we were trying to do. So set prompts, that makes sense. Okay, so then here's the prompt callback that we want to do. So let's take a look at how all this works. Oh, and start insert is what's obviously making me go and insert. That makes sense. Okay. I was going to say, oh, I didn't know how that was actually working and how I was starting an insert. Start insert. Start insert mode. Yeah, okay, whatever. Okay, so Vim function prompt set callback. When buff number function, yeah, which takes in the text that the user just entered. Vim API NeoVim when close. Okay, so this is also what I want to do. Like I want to just close the window. True. What is that? Force NeoVim when close. Yep, closes the window like close with a window ID. Okay. If text is nothing, then Vim schedule function Vim API NeoVim buff delete plenary window force true. No, actually, I don't know. Like, how does this work? Because we're closing the window but keeping the buffer. LSP buff rename text. Nope, don't want to do that. nothing. We'll just keep this in there for now. And for this, we'll just say print text. Yeah, I just want to see how this works. All right, so we get rid of this. Do Scala completes. We're gonna try org, Scala meta, boom. Actually don't know where it completed to, but okay. Well, I suppose there's like no way. Actually, where did it go? Oh no, so yeah, so it did print it out here. Ooh, I put on I put a message on Twitter for somebody to give me like a minimal Bazel bleh. This is the exact one that we were just trying a little bit ago. That's funny. Let me respond to this. I just tried that one. Options with BSP. Gotta put a laughing face in there. Boom. Huh, that's funny that like the same one that we just tried was the one that you recommended. All right, so okay, so it spits it out now. So then, okay, so what I would expect to happen now. So if the text is not empty, oh yeah, let's try it with empty just to make sure. Scala complete, boom. Messages should say nothing, yes. Okay. So if the text is not complete, what we're going to do, here's the tricky part, right? So the whole completion thing up here is based off the idea that like when we create a new completion, we already have like a separated org and an artifact. To be honest, we may not even need that. Like maybe it was just my like, I was trying to have it be fancy and say like, oh, like later on maybe we would know what the org was and what the artifact was. But like if you look at how we do the completes, we like the args that we pass in, we just take the org, a separator, and the artifact and mash them together anyways. Like we never actually just look at the org, for example, so maybe it doesn't make sense at this point to even differentiate them. Like later on maybe it will. And the reason I say that is because if we don't differentiate them, then we can reuse all this logic in the completes to do exactly that, to just complete everything. So I think what I'm going to do is actually, when we first call complete from line, we'll grab the org and the artifact, and if there is an org and an artifact, then we'll call a new completion, and the new completion that we have will just be an org plus a separator plus an artifact. So later on, like to do it, later on, if we really need to differentiate, I don't even know how to spell differentiate between the org and artifacts, we can. But for now, it's just easier to smash them together. So we can reuse all of the completion functionality. I think this is fine. So let's go to new. We'll have to change this because instead of so org and artifact will now just be completion, and we'll get rid of org and get rid of artifact, and instead this will be completion string, and this will be completion, Yeah, let's just rename this the same thing. Completion string. And then down here, when we put this together, it already has a separator in it, so we don't even need to worry about it. Yeah, actually, this just makes everything like way easier. We can just get rid of all this. The complete can be right on the self-completion string. This should change a little bit because instead of matching on just one separator, this will need to return 2. I actually don't know how that, like, don't know the API well enough to know what that looks like. If match in this case will return twice. Lua string match. No, I want to know like if it will return twice, like 2 positions or not. Lua pattern matching. No. Here, let's do this. Jump Lua. Oh, actually, let's go back here. Grab this. Go to here. Match that Lua. So let's say we have local C equals. Because really, like, what our completion would actually look like is this. And let's say that's it. That's it. That's the current completion string. We could have match. And what does this actually return? Whoops. Lua match. Does it seriously return 1? What? Local x equals c match. All right, what am I doing wrong here? So this, as mentioned above, the uppercase version of the class. All right, let's find a different example maybe. Looks for the first match of pattern in the string S. If it finds one, then match returns the captures from the pattern. Otherwise, it returns nil. Ah, okay, that makes sense. If pattern specifies no captures, the whole match is returned. A third optional numeric. So can we just like define 2 of these and then see? Returns a string. Yeah, I want to find multiple occurrences. String returns an iterator function so that each time is called. How about find? Looks for the first pattern of first match of pattern. How to find multiple occurrences? Find multiple occurrences in string Lua. Yeah, this is what I want. gfind. A special meaning in patterns used for non-greedy repetition. You need to escape it. Use the pattern. Boom, boom. You can actually do this in a one-liner using gsub. Huh, okay. So what was gsub? Lua gsub. The gsub. See, now I need to go back to the matching, I think, actually. Okay, let's try this out. Gsub. So this should print the first one, I believe. Whoops. Match. could actually do this as a one-liner. Also local. So the first thing we don't want, the second one would be accounts. The third one, we're not substituting anything. So the accounts is 2. So then, yeah, so let's just check this out. So this is 2. If we didn't have this, we'll give this one a name of 1. So let's do 2, count 2, 1. So this, in theory, should print out 1, 2. Maybe. I don't really get why the diagnostics are showing up. Okay. 0, 2. Oh yeah, of course. Okay, so that does exactly what we're looking for. Cool. So we'll do, oh yeah, I know what we're doing. So we'll do this, local counts. Yeah, so instead of trying to match on the self artifact, we'll say for the self completion string, gsub, boom, we'll want 2 of them. So then we'll check to see if count is 2 here, count equals 2. Then we'll reverse. Yeah, so this is what I was talking about with like reversing it when you're at the last stage and you have everything else but the versions itself. This will reverse the versions correctly. So let's make sure we're not missing anything else between org artifact. Okay, artifact. If the completion string has 2, boom, we assume that this is the last step of the completion and therefore reverse the order to have the news come first. All right, so let's make sure this works. So same thing, Scala completion. Oh, nope, that's not what I want. I want line completion, Scala line completion, Scala completion line. Actually, I don't even remember what the mapping is that we just made. I also don't love these mappings. SLC. SLC. All right, still works. It's not fully working actually, I don't think. SLC. SLC. 212. Yeah, so something's definitely going wrong because the second one that we did when we complete the artifact doesn't seem to work. Probably because we're trying to like set the artifact or something. So let's go. So yeah, so like after we complete from the line, we say we want to complete the artifact. When we look into complete artifact, yeah, exactly. So ongoing completions artifact. Artifact no longer exists here. Instead, we have current completion. Or no, completion string. Completion string equals line contents. Ooh, actually that's not what we want. So yeah, before we could just like completely replace the artifact because it was all like one thing, but instead, oh man, now I'm like second guessing removing org and artifact because it's nice to have the differentiation. Maybe we should have like org artifact. Nah, maybe that's like overcomplicating it. Like we can do that later. So the ongoing completion string equals. Oh no, this is like way harder. We can't do this anymore. Yeah, because we would have to, crap. The reason why this was nice before was because we could just completely override whatever the artifact was and not need to worry about it, where now like we're only completing either like the organization if we only have an org, or we're completing the actual like starting to complete the artifact. So like only the portion after the actual colon is changing. So if we can leave it this way if we want, but then what we would need to do is like, let's say at this point we have like org, Scala meta, mdoc, okay? And then we just triggered a completion, and the completion we got is mdoc 212. So what we would need to actually do here is like go back to the original completion string, delete everything after the colon, and then replace the string with this. So that's why like having the artifact and organization separated is pretty nice, I would say, because it allows you to just like replace the artifact because we know we're at the artifact stage. So I actually want to keep that. I would rather almost I would rather detect if you're like, I'd rather split up the organization and artifact when you're just doing like a generic completion where you're like giving something first then changing this. So like actually like we're gonna redo all of this, which kind of sucks. So frick, let's get rid of all this again. We're going to go back to the org and artifact stuff. Yep. And instead of handing, okay. Yeah, so that's a bummer. So instead, what we need to do down here is parse the user's input to pull out the org and artifact, or like maybe not even have both, like at this point. Yeah, so let's just make sure I didn't screw something else up. So line, Scala line, Scala complete. Yeah, so like let's say, oh, I want org Scala meta. Yeah, see, here's actually the crappy part is like if the user passes just this in, then we need to complete assuming that we don't even know the organization yet, right? So like if they hit enter, this will do a CS, we want this to do a CS complete org Scala meta. Okay? Then they'll, I'm assuming there's only one option. I actually don't know why this shows up twice. It's kind of a little bit weird. So that's what they want. So then once they would select, yes, I want org Scala meta, we would add a colon to it. And then we would get all this stuff. So if this is what they type in, then we would have to complete this, and it wouldn't be. Yeah, so we can do this pretty hacky in the beginning and then maybe like fine tune it later, but like the same way that we do this match up here, we could do that here, right? We could do like if the self artifact no, so yeah, it'd be text match. And yeah, we're looking for a line separator. What is exactly, I always forget like what exactly is being returned by all these. Lua string docs. Lua docs. Nope, that's not where I was looking. Lua strings. Actually, I need to find like a really nice like docs that I like refer to often, because I feel like whenever I'm searching for stuff, I'm just going all over the place. String library tutorial. Match, not gmatch, normal match. Extract substrings by matching patterns. 2 questions. Yeah, so maybe like, to be honest, find is maybe more appropriate here. String find pattern. If the first occurrence of the pattern is if the string is passed, if an instance. No, because I actually probably want to do like a similar. So I'm second guessing the order I'm doing these things in now, because realistically we're trying to, we want the same functionality that we have up here with SPT, right? Like, but we want to do it on Ivy stuff. So instead, I think actually instead of finishing this, what we should do instead is change like the current functionality to also account for her like mill stuff, and then we could reuse the logic to grab these two things there, because it'll be the same thing. The way that like we're like detecting a mill dependency would be the same way that we would detect like the Oregon artifact coming out of the what the person would like pass in. Check this out for inspiration of your Coursier thingy. Check this out. Scala deck search. I've actually heard of this before, I believe. Huh. Interesting. It's actually interesting that they use Scala decks for this. I would sort of expect them to just use Coursier for this. Like, I'm curious behind the scenes how this works. I'd be very surprised if it doesn't use Coursier. It doesn't. Interesting. Oh, it's written in Scala JS as well. Cool. Yeah, so like very similar type of functionality that we're trying to achieve. I wonder if Scala Dex also just like automatically gives you it in the correct format. Fetch. Yeah, I want to see like how it searches for it. So input box, group ID, artifacts. Oh no, it actually puts it together. Heap puts it together here. So file name, dependency, file name ends with SPT and ends with Scala, then interesting. It'd be cool if it was like the ability to also like detect, do I want like a JavaScript dependency as well, and add another one here? Or how do you know like the dependency that you're grabbing, how do you know it's not like a Java one and you only want one here, for example? So like there's some other things we could do here too. Actually, is this correct? Shouldn't there be a backtick here? Or am I just going crazy? How does Mill do that actually? Ah, no, it is this way. See, the annoying thing is that, or one of the annoying things is like the way that we do imports in worksheets are very similar but different. So you actually have three different ways to do it. Yeah, because here you have $IV. But this part's still the same. So the parsing that we could use is similar. Actually, does CS complete tpool cat? If you do 1, it'll give you those options. If you do 2, will it? Yeah, I was actually curious if I do 2, if it would like detect the Scala version locally and then use that, but no, it doesn't look like it. Doobie core. Oh no. Doobie core 212. Or is it supposed to be here? Nope, it doesn't like that. Okay, whatever. Sidetracked. Okay. So let's try to jump back where we were here. Yeah, so first we need to handle this in Mill as well. So SPT style, what we're trying to capture is when we have org ID, artifact ID, and that's really all we care about, because like we also have this thing down here, and then we have version, but we're not capturing the version here. Where for Ivy, we're going to have something a little bit different. We're going to have org ID, 2 of these, or 3 of these, I guess. Artifact ID, and then version, right? Yeah, and if I'm not mistaken, this is the same thing for, like, we could do this for Scala JS, I believe. And is it one for Java sources too that way? So yeah, so if we're gonna like copy this, so let's just say we just do Ivy org, Ivy artifact, probably be something similar. So the match that we're trying to do is like again, this is a really greedy match, but we're only ever doing it on one line, so it doesn't really matter. It doesn't care. And like we'll code in the logic here in a little bit, where like depending on what type of file we're in, if we're in an SPT file, we'll look for it this way. If we're in a Scala file, we'll look for it this way. But then if we're in a worksheet, we'll look for that's another thing. Like we have to do worksheet too, also do worksheets, because it might be a little bit different, the pattern, than like a normal Ivy one. So really, we'll have, so I think that, so yeah, this is a space plus these two, which are, oh yeah, so like this is saying we'll have at least one, right? I don't actually know if the colon is a special character in match at all. I don't actually remember. I don't know, we'll try it out. We'll just go with the assumption that it's not. So let's do this, an optional one for the second, and then an optional one for the third. There's also going to be like none of this. There's going to be no white space. Actually, yeah, it'll start with that. So like we'll get rid of the white space. Actually, maybe we could just do this, start with this. So this will say like we need 1 colon, possibly a second one, possibly a third one. We'll have to fix this because this will be like, again, this will grab too much stuff, I'm pretty sure. But maybe we can do this, like here's an example. So we can do Ivy, then after Ivy we do whatever come next. Oh no, I'm in the wrong one, sorry. This one. So we have Ivy, and then this, whatever comes in here, which will be the artifact, or sorry, the organization. Then we'll have at least 1, possibly 2, possibly 3. Then we don't have a space anymore. We don't have this. Then we'll copy whatever, we'll capture whatever is there. This will be the artifact. We no longer have a space. We no longer have this, but we have this instead. And then, yeah, whatever comes next. So I want to say this will actually do it. So let's try this, just to give us an idea. Oh, actually, no. Yeah, let's do this. Be even easier. Ivy org and Ivy artifacts. All right, so let's try it out right here, which would be line complete. Nope. Scala line complete. Nil, unable to find a dependency on this line. All right, so it didn't work. figure out why it didn't work. So we have Ivy. When it's followed by this, we'll capture the organization. And then we'll have 1, possibly 2. These might need to be escaped. Let's try that. I don't know if that's actually true or not. Could be. That would be, whoops, the easy thing if it is. Let's close this. We don't need it anymore. Scala line completes. Nil. No. All right. Plus anything repetitive. Maybe this is it right here, actually. We don't need this. Because I was accounting for extra spaces. So maybe actually these escapes aren't actually necessary, so let's get rid of those. Followed directly by, yeah, okay, let's try this. Nope. Scala line complete. Yep, perfect. I captured a little bit too much though, dang it. So yeah, we have, it captures org, Scala meta, and one of the colons, and then mdoc. So it does capture some of it, but let's see why we captured a little bit too much. Yeah, I think it's because I'm actually not 100% sure. I'm assuming that it might be because this is too greedy. Like this is capturing, yeah, just a little bit too much, where really we probably want this to only be like, I guess it could be a lot of things. It could be chars, dashes, periods, but it can't be this. Which I'm actually surprised that it did this. Scala line complete. Org Scala meta mdoc. Let's see if it still finds it with 3. Scala line complete. Oh, now it finds 2. Yeah, I don't know why it doesn't like stop here. I don't know, I'll have to look more into that. But that's pretty close. But I'm gonna have to call it a night here, I believe. But thanks for coming and hanging out. Hopefully like some of the BSP stuff that we went over was useful. Yeah, I plan to do some more work on this plugin as I keep hammering away at it. I want to get some more stuff figured out because I think this will be kind of useful and kind of cool to have, and see what other like types of utilities we can also have, like see if we can get like the CS resolve thing working, and just really like any other like Scala utilities that aren't exactly like part of Metals but could still be like really useful to have in NeoVim. I really want to include in this plugin. So yeah, we'll keep working at it and keep adding as much stuff as we can into it, but for now that'll be good. But let's try to thanks a lot, appreciate it. If you can think of anything like that would be good to add into a plugin like this, just like random Scala things that would be helpful to do in NeoVim, definitely throw them my way. But let's see if we can find somebody to raid real quick. If you have any preferences or thoughts, feel free. Let's go into science and technology. Whoops. Programming. All right, who should we take a look at? Let's go down to the bottom. See what people are working on. Java. One day I'm just like really hoping that I'll be looking and just see like boom, Scala or something. So like somebody will be working on something in Scala. It'll be like make my day. Flutter game dev stuff. Quiet coding. Code archives. I've watched TS coding stuff before, so it's the one that like piques my interest kind of at all. So let's jump into there. So yeah, thanks again for hanging out, guys, and I'll see you soon.